Hello students, welcome back to my YouTube channel Mathematical Lens by Namita. In this video, we are going to continue chapter number 7, A Tale of Three Intersecting Lines of Grade 7 Mathematics of the new NCERT textbook Ganit Prakash, and we are going to cover up question number 3 and 4 of Figure It Out exercise, which is the last exercise of this chapter. Question number 3. Construct a right angle triangle ABC with angle B 90 degree and AC as 5 centimeter. How many different triangles exist with this measurements? Right? So we have only one angle and one side length. That too, where the angle is different and the side length is AC and angle 90 degrees at B. Right? They have also given a hint. Note that the other measurements can take any values. So take AC as the base. What values can angle A and angle C take so that the other angle is 90 degree? So let us solve this. Now first we do some calculation, like since AC is given as 5 centimeter and angle B is 90 degree, right? So as we know that according to angle sum property, angle A plus angle B plus angle C will be equal to 180 degree, right? Angle sum property. So if we put the value of B as 90 degree, so we get angle A plus C is equal to 180 minus 90, that is 90 degree, right? So the sum of the remaining two angles has to be 90 degree. So there are different combinations possible for 90 degree. Like you can take 50, 40, then you can take 60, 30, like that. There are many possibilities for the other two angles. So they have asked how many different triangles exist with this measures. So infinitely many triangles are possible. Okay, so this is the base. First of all, we understand the basics and now we try to construct. So we will take AC as the baseline because that is given 5 centimeter. Right? And B is 90 degree. We don't have B right now, the point B. This is A and C. So out of the many possibilities, suppose we take angle C as 40 degree. So we keep this point here and we mark a point for 40 degree and we join this line. Draw it a little longer, and then if this is 40 degree, this has to be 50 degree because the sum should be 90 degree as we just calculated. So now we just match this and draw, show 90 degree here and join these 2 points. Right, so this is 50 degree, this is 5 centimeter, and this has to be 90 degree. This will automatically fit in. Angle B will be 90 degree. So 50 degree, 40 degree, 90 degree, the sum is 180 degree. And we can have many possibilities. Like I'll show you one more with 60, 30. Okay. Now again we take AC as the base, 5 centimeter. Right. And then, so this is point A, this is point C, this is 5 centimeter. At C, now we take the other combination 60, 30, right? So if we take this as C as 30 degree, match the baseline first, and we are going on the left side, so 30 degree will be the outer scale. Take care of the scale, otherwise everything will be wrong. Join these 2 points. Then at point A, we take it as 60 degree. Here we will see the inner scale. And now join these 2 points. Right, so this is 30 degree. This is 60 degree. This is point B, and it has to be 90 degree. Right, so I have shown you 2 possibilities. You can try with other combinations as well, like you can take 10 and 80, 20, 70. Right, you can even take 45, 45. Try with that. Okay, an isosceles triangle. So there are infinite possibilities for this answer. And now we'll do question number 4. Question number 4. Through construction, explore if it is possible to construct an equilateral triangle, that is a right angle triangle, an obtuse angle triangle. Okay. Also construct an isosceles triangle, that is a right angle triangle and obtuse angle triangle. Right. So we have to explore this. So let us try out. So let us try to draw a right angled equilateral triangle, though we know that in an equilateral triangle all angles are 60 degree. But through construction they have asked us to explore this so that we understand it better and we remember it forever instead of mugging it up. Right, so we take BC as the baseline. All are 5 centimeter. Angle B is 90 degree, so we are taking BC as a baseline 5 centimeter. Right. Now we'll draw 90 degree with the help of protractor. Okay. We can even use the set square and the scale as we did earlier. So here is our somewhere point A. Now we want 5 centimeter. All the lengths should be 5 centimeter because it is an equilateral triangle. Fine. So what we do, we keep this as a center and we cut an arc 5 centimeter. We keep B as a center and with the same radius we cut an arc. Where is the point meeting? It is meeting somewhere else. Right? So we are not able to construct the triangle. The angle which we are getting is 60 degree. That also can be checked with the help of this. So the point of intersection, you can see this is 60 degree. Right? And 90 degree is this. This much is 60 degree. So it is not possible. So we write the answer as a right angle equilateral triangle is impossible. We have explored it through construction as all angles in a triangle can never be 90 degree, right? See, all sides are equal, so all angles should be equal. So if all are 90 degree, the total will be 90 plus 90 plus 90 will be 270. And according to the angle sum property, the sum should be sum of all angles of a triangle should be it is 180 degree, right? So it's impossible. And in an equilateral triangle, all angles are 60 degree because 180 divided by 3 will be 60, 60 each. So this is not possible. Now we try to draw an obtuse angle equilateral triangle. Okay. So here we have taken the measurement DE is equal to EF is equal to DF is equal to 5 centimeter. It has to be an equilateral triangle. So all sides are equal. So we take DF and one angle we have taken as 120 degree, angle F. So for angle F, we take DF as a base, which is 5 centimeter, right? Now at point F, we draw 120 degree. Now see this, you have to be careful. You have to see the outer scale in this case. And so this is 120 degree. Fine. Now we want the other two sides as 5 centimeter. So we can take this only as 5, yes. So we take F as base and cut an arc. No need to form circles, you can just cut an arc so that they meet each other. Right, now see the point of intersection. Where are you getting? It is over here, not anywhere at angle 120 degree. Right, so again this is not possible. So again the same logic, like obtuse angle triangle is not possible, as all the angles of a triangle can never be 120 degree, right? So we write the conclusion as obtuse angle equilateral triangle is not possible as all angles cannot be greater than 90 degree. It cannot be 90 degree, then how can it be greater than 90 degree, right? The sum, if I what we have taken 120, so 120 plus 120 plus 120 will become 360 degree. 12 threes are 36, right? So which is not possible in a triangle, right? So this is first part of question number 4. Now we'll solve the second part. Now in question 4, the second part is construct an isosceles triangle that is a right angled and an obtuse angle. So first we try to draw a right angled isosceles triangle and we take the sides as two sides BC and AB. Suppose we take it as 5 centimeter and angle B we take it as 90 degree. Okay. So now we take the base as 5 centimeter. It is B. This is C. 5 centimeter. Then at B we draw 90 degree angle. Taking BC as a base. We draw a ray because with this we need as 5 centimeter, right? So we use a compass. This is already 5, so we can use that. And we cut an arc over here. So it's an isosceles triangle, so we need two sides equal. So we have drawn 5 centimeter, 5 centimeter, this is 90 degree, right? So that part is satisfied. So then we can just join this is point A. We join AC. So we get a triangle ABC, which is an isosceles triangle as well as a right angle triangle. Now, these two sides are equal, right? So naturally, these two angles will be equal. And this is 90. If we subtract, like if we take angle A plus B plus C is equal to 180 degree according to angle sum property. I have written in short form ASP, right? So B is 90. So A plus C is equal to 180 minus 90 degree. So angle A plus angle C would be, the sum of these two angles will be 90 degree. And two sides are equal, so two angles will also be equal, right? So if I take this as angle 2, angle A is 90 degree, so angle A will be 45 degree. So these two angles will be 45 degree each. Here there are no other possibilities. Fine, so triangle ABC is the required isosceles right angled triangle. Now we try to draw isosceles obtuse angle triangle. So I've written the measurement BC is equal to AB is equal to 5 centimeters. So two sides I have taken as equal. 5 centimeter, you can take 6 centimeter, 7 centimeter. I've just taken a convenient radius so that it's easy. Now at angle B, this is point B, this is point C, which is 5 centimeter. At B, we draw the angle as 120 degree. Here we see the inner scale and we join these 2 points. And BC is 5, AB is also 5. So we take this as a center and cut an arc so that we get our point A. And then we can just join AC. So an isosceles obtuse angle triangle is also possible to draw. So this is 120 degree and this is 5 centimeters. So two sides are equal and one of the angle is an obtuse angle. So thus triangle ABC is the required isosceles obtuse angle triangle. Fine. So this is answer number 4. With this, we complete the figure it out exercise as well as the chapter. We'll continue with the next chapter. We'll start a new chapter, which is the last one, fractions, soon. So if you have any doubt in this chapter, you can write to me. I'll try to solve your problems. And if you have not yet subscribed my channel, kindly subscribe it. Thank you.